So let's see. Okay. Homework number 3 or 4, somewhere there should be discussion of Fibonacci. Number 6. By the way, there's still 2 number 6, or is it fixed now? I don't remember. No, it's still there. I'll fix it today. So question number 6 asks you to rewrite the Fibonacci number generator that you wrote using recursive functions. Now this time using a for loop. So this is the original. Remember we had this user input checking section of your code, your function, and then a nested function that finds the Fibonacci number for the input integer, right? So now what this question wants you to do is to download this function and modify it using MATLAB time it function so that you can time get fib. But I haven't told you about time it function yet. So let me go on with lecture, and then we can get back to this question at the end of the lecture. So let me tell you first about while loop, and then yes. Not this one, then one after this. It will be always synced with the homework from now on. I mean, it will be synchronized with homework submission time, date. And the homework is no. The homework is due. It says, what does it say? Okay, so it's not due next Monday. It's due 1 week from now. Somebody's phone is ringing. So I told you last time about for loop. The while loop also has a very simple syntax. Instead of a for, you're asking your code to wait until a condition happens, to repeat some set of tasks until a condition happens, and then you get out of it. As simple as that. So like for example, I could say x equals real max of, is that correct? Yes. So what is this number? You have any ideas what this number is? Real max. What does the function real max give you? No ideas? So definitely it's going to give you a real number, right? So, and it's maximum. So it should be the maximum possible real number that you can get given your computer and the MATLAB version that you have, right? So this is the maximum, the biggest representable number by your computer and your MATLAB software, right? So you cannot have a number bigger than this, right? So now let's say I want to write a while loop that divides this, or takes the log of this number x until we hit a number that's less than 0. And you know what's the log of the negative number? What is it? Well, the log of a negative number doesn't exist. Yes. So it should stop when it doesn't exist, right? Or when we go below 0. So what do? We say yx is larger than 0. Then I want to get the log of x, right? So I can say x equals log of x, and then I cannot go back, so I have to end it here. That looks correct, right? So I get the log of x until it hits a number that's less than 0. So this should work. Okay, if I wanted to repeat this again, all right. Oh, x has changed, so we have to call again real max. So x is the biggest number again, and then I write this for loop. So what happened here? So we had the biggest number, we took the log of it. The log of it is 709. Then the log of 709 is 6. The log of 6 is 1. Log of 1 is 0 almost. And then log of a slightly positive number is a negative number. Log of a number less than 1 is negative. So it stops. But it still prints the last number for us. Right? The last negative. The last number which is negative. So why does this happen? Oh, I see. Because do you have any ideas why we get the last negative number? Because we wanted this loop to only print the positive numbers for us, right? So what happens here? Yes.
Yes, go ahead. Because while loop checks this can't be added. So
yes.
It iterates one more time and then he realizes that x is less. Or sorry, checks it at the beginning.
Yes, I think that's correct. Yes, it checks it at the beginning actually. That's right. But like for example, in other languages like C, for example, you check it both at the beginning and at the end. But as far as I know this, in MATLAB you have it only at the beginning. All right. So say while x is larger than 0, then repeat this task. But when you get the last number here, which is less than 1, log of number less than 1 is negative. So you print this and then you go back. That's a negative number, so it's not larger than 0. It stops. So that's why you get the last number. That's correct what you said. Okay, so as simple as that. There is nothing more complex about while loop. And then again, you can also use break and continue statements in while loop. For example, you could have the same statement again, but here you want to make sure that when you hit a number less than 10, you want to quit. So if x is less than 10, then break end. Okay, simple as that. Now, if I do this, then which numbers would not be printed then? Almost all of them, right? Only the first one, I guess. See, I say if x is less than 10, then break the loop, right? So what does happen? X is 709, it's not less than 10. X is 6, it's less than 10, so it's not going to be printed, I think. Or it's not going to be, it's going to be evaluated, I think. Right?
Yeah.
So probably we'll get 2 numbers. Certainly we'll get 2 numbers. We got nothing. That's because we redefined x. So now, if I copy this, you get 2 numbers, right? And it's because the second time, x is still larger, x is 709, but you take the log of it and you print the value of it on the screen, and then you go back to check the conditions, right? So you can also use break and continue. So keep that in mind, just like for loop. And then I'm going to skip the example, but let's solve this one using a while loop. Let's write a get factorial function that calculates the factorial of a number like 4 using a while loop. So how do you solve this problem? Again, you have to start thinking about the problem in a logical way. So factorial is n times n minus 1 times n minus 2 times 1. right? So if you want to write a for loop that calculates this for you, how would you do it? So your function gets an integer number, that's n. So you write a for loop that starts with n and goes away all the way to 1. So you would say for I equals n to -1 to 1. What does -1 mean here? It goes in the negative direction, right? So you could also start in the opposite way. You could say 1 to n. That's also fine because there is no direction in this calculation. You could start from the end or you could start from here, right? And then you say you have to, so you have a variable that is equal to the product of all these terms, right? So you have to initialize this term. How do you initialize it? What should it be initialized? Should we set this variable? Because we have to define a variable here. I say the factorial is something times something times something times, right? So I'm changing the value of factorial every time. I say factorial is what? Does it make sense for you guys? So I could write this factorial as this term. N factorial is n times n minus 1 factorial, which is equal to n times n minus 1 times n minus 2 factorial, and so on, right? That's this, right? So that's why we wrote a recursive function for factorial, because you see, if I want to calculate the factorial of n, that is n times the factorial of n minus 1, right? So I can call the function that I wrote to calculate the factorial repeatedly. If I want to calculate the factorial of n, I call get fact n, and then get factorial n minus 1 times n, and then get factorial of n minus 1 goes and calculates get factorial of n minus 2, multiplies it by n minus 1. So we can do the same thing using for loop here. All I need to do is to initialize factorial variable here. So I set the factorial to 1. That's going to fix it. You see what happened? I bet if you try this code, it's going to work. So you write a function that takes the number n, and then you define a variable, the output variable fact, or factorial, whatever you want to name it. Its value is 1. And then you do a for loop here. Say for I equals n negative 1 to 1, and then factorial is factorial times I. It should work, yes. But this is a for loop. Now we're going to write a while loop for this same problem. So let's try this and then see if we can get the correct answer for factorial of 4. Yes? Okay. Yes. The one that I told you was right. Now we're going to convert this to a while loop. How would you write a while loop version of this? Because in the first call, value is not really important, right? So, what other number you could set it to? So let me explain it for everyone. So, question is, why do we set a factorial to 1? Why do we initialize the variable to 1 at the beginning? Does anybody have any good answer for us?
You have to keep using it, so you have to use that output each time you multiply.
Right. But what's the problem if I set this to 0, for example?
Then you will.
Yes. That's correct. But
the factorial, like the symbols factorial is 1. The factorial 0 is 1. So like,
Yes.
yes, but there is a, yeah, that's true, but there is a, that's right. I think our code is not robust because if the user enters 0, then this is not going to work. Right?
It gives 1, but like I think that's because.
Oh, that's correct. Yes.
But is that because like the flow just doesn't do anything? It just gives
Yes. Yes.
zero,
Exactly.
it's like this number.
That's right. But I didn't have that in mind, to be honest. The reason I set this to 1 is that if I set this to 0, you have to initialize it because you're using it here, right? So if you remove this line, if you remove this initialization, then this for loop is not going to work. It gives you an error because it says factorial is not defined, so you cannot use factorial in this assignment. But the problem is that if I set this to anything other than 1, what happens? So if you set it to 0, what does happen? You get factorial equals 0 times another number, which is 0. So you will always get 0, right? If I set this to anything other than 1 again, like 2 or 3, what's going to happen? You get an extra factor here that's not relevant to this factorial. I could set this to 10 million, and that 10 million number that enters this factorial calculation doesn't have anything to do with this factorial number, right? So whatever I set so see what happens with this calculation. In the first round of the for loop, I have factorial times n. What do I get on the next round of this for loop? So I get, again, the previous value of the factorial times n minus 1, right? So I get factorial times n minus 1. How about the next round? It goes like this, right? So it goes to lower and lower numbers. So I get the same thing times n minus 2. And when you hit the end, you get factorial times all these terms times 1. So this is the factorial that we wanted, n factorial. These extra terms, the initial value of factorial that we had to have it in the for loop, is an extra term. So if we set it to anything other than 1, it's going to ruin the whole calculation. So if it's 0, it's going to set all the calculation to 0. If it's 2, it's going to multiply n factorial by 2. If it's 1, that's the number that we want. You can test it. You can initialize this to 2 and see what you get. I bet whatever you get is twice the correct factorial value. Okay, then if you have done this already, let's try to implement the while loop version of it. Does it also calculate 0 here? Yes. Yeah, question?
Oh, I was just wondering if you
Factorization? Oh, vectorization. No, not yet. But you have done this before. It's very simple. I'm just going to name it. Say whatever you have been doing so far is vectorization.
yes.
You get 0 all the time. Because when you set this factorial, you need to add 0. What's going to happen? Factorial equals 0 times 5, right? And then that's 0, right? So in the next iteration of the for loop, it says the factorial, the new value is factorial 0, which is 0 times the next value of 5, which is 0. It's like the one that we did. So in the first the value of the second round, the and minus. So this initial value of remains the exact. So whatever you set it to, it's going to have the entire factor. You can try it. Attendants will still return double the value of that.
And if I do 0, it doesn't even go here. It's just like white. Like now, it's looking like that. They all work. I think it was maybe but I yes, for line 1, then you go 5 equals 5, and then it'll go to
So I did while and then I changed and
So
where you go to
first number to the last number and multiply each time the number by itself. Whatever we do, so you have that times and then now
Well, really easy. So, break, I'm going to a while, and I say if back greater than 100. Stop what it's doing in the while right then to the beginning of like let's say I have a whole bunch of like 10 lines. I have like a continue like in the middle, like just something continue. Then if that's true, go to continue, then it won't.
Next time we run the for loop, I equals n minus 1. FAC is the first FAC being n. So this is FAC n times n minus 1. Okay.
Great, we'll completely
So it's working continuously at the
yeah, so like 5 it'll go through, and if this is true, we're going to continue. It won't do any of these lines.
Write this equation again. Did you get the while loop version of it working? How many of you got it?
And if this is true again.
Okay, good fraction. But let me explain the for loop version of it. Bless you. So the for loop version of this would be written like something like this function. But some of you have got some really weird errors in their code that I cannot debug it honestly because it just sounds really weird. So output equals get back of n. Then I want you to follow a syntax, not a syntax, a set of conventions that makes your code much more readable. So whenever you're inside a function, I would say always press a tab so that everything appears inside of the function. Okay, so that you understand that you're not in a script, you're in a function, right? Again, that's a convention, but if you follow it, that would be great. Okay. Also inside the for loop, definitely for the for loop, if not functions, then for the for loop and while loop, definitely put everything with a tab character at the beginning. Okay. A few spaces. You don't necessarily need the tab character. You could also put spaces. Okay. 4 spaces is the convention for MATLAB. In Python, I think it's 2 space or 4 space. Okay. But that's a convention. That's not the syntax or standard of the language. So I say initialize the output to 1. I did there, and for I equals 1 to n negative 1 1 and output equals output times I. Okay, so this should work now. Okay, so now if I call getFact with 4, I get 24. So those of you who got some weird bug in their code, can you try this and see if this one works? This is very similar to what you had in your MATLAB code, but I think probably you had some other file with the same name in your MATLAB directory that's causing the problem. So this is the for loop implementation of it. How would I implement it using a while loop? So I'm gonna comment these lines and say while I have to initialize, no, let me see. So let's just name it counter. Counter equals n. Then I say while counter is larger than 0, do this. Output equals output. I don't even need output anymore. I could just set this to output and remove this line. So I say the output is n, and then while, no, we still need the counter, so I think I was wrong. Well, because n is fixed, n is the input number, right? So you mean, yes, but it's not a good idea. If you try this, then and you get used to it, it's not the same case in compiled languages. If you go to compiled language, you are not allowed to change the value of an input variable. So you keep in mind, if you get some input variable as some variable as your input argument, you should never change this value because it's going to cause confusion in your code. And in many languages, it's not even allowed. So I'm not sure if MATLAB allows it or not. I have never tried it because it's just so illegal in other languages that I never tried it myself in MATLAB. But does it work?
If you like ask for an input rather than like if you're going to call.
Yes, if you ask for an input using the input function inside of a function, then that's different.
Okay.
Yes, you can manipulate it, but we can test it. I'm not sure if MATLAB allows you to change the value of n. We could test it. Yes, it does. Okay, so that's a weird again rule in MATLAB that you have to be careful because if you go to other languages, that's not always the case. So normally you should never change the input values of a function. So I say output equals output times counter, and then what else do I need? This loop will go forever if I run it right now because counter never changes, right? So I need to change the value of counter at each iteration. Counter equals counter minus 1, okay, and then end. So this should also work. Now if I say get back of 4, again it gives us 24. Get back of 0, I'm not sure. Let's see if it works or not. Yes, it gives us 1. Why does it work? Any questions about this function? The while loop? Nothing?
How is that different enough from just saying n equals n minus 1?
Oh, you mean here? No difference. In MATLAB, it doesn't make any difference. So counter is redundant in MATLAB. I could remove this and say while n is, but you're not allowed to do this in other languages because of this prohibition. I've become used to not redefining the input variables to a function. So you can in many other languages, you're not allowed to manipulate, change their input values. Yes. You know, basically, you can change them. It's not that you cannot, but it's a very bad programming habit. I was wrong. So you can change it. Even in the most strict languages, you can change the value of an input variable, but it's always not a good practice. So you should never do this. Okay. Because sometimes the input argument could be also the output argument in other languages, right? And if you don't know what you're doing, then it can cause a lot of confusion. So you better not manipulate the input value. Yes.
Wouldn't you get 1?
If I said -1, that's correct. Yes. Good observation. So why do I get factorial of -1 as 1, which is wrong? Exactly, yes. So you have to say, if you want to make this code robust, you would say, if, you could also try and catch, but you could say if n is larger than 0, then do this. But again, I told you, whenever you use if block or while loop or for loop, always put a tab before them so that you know, you can see the structure of the code, right? And then else, display wrong input. Okay. End. All right. So now if I run this code with get factorial -1, it says wrong input and quits. Right? Okay. So let me tell you one more thing, and then we are gonna go to the problem, to the homework problems. So let's go to the problem number 6 about Fibonacci sequence. This one, right? It requires you to time the performance of your function. So let me tell you about time it function first, and then time it. Okay. So there is a very useful function called time it in MATLAB that helps you to test the performance of your functions. Time it, just as the function name says. How do you use this? Let me see if I have an example here for you. Yes. So you have this factorial function that we just wrote, right? Get fact. And now we want to test its performance. You can use time it function to test the performance of your code, get fact. So how would you do this? You would say time it just like a function call. But this is a function. It calls another function. So so it takes a function as an input argument. So the time it function is a rather strange function because it takes another function as an input argument. So I define a function handle to this function that I have, get fact, and then I set the number to something big. Let's say 10,000. Just to make sure 10,000 factorial is just too big. It doesn't exist. So let's try 100. Okay. So that's okay. Get fact of 100. Undefined counter. Well, apparently it didn't work for me. Oh no, counter is not. Okay, so it works now. So if I say factorial of 100, that's a huge number, right? So if I wanted to time this function, see how much time it takes to calculate the factorial of 100, it's actually very small. So I'm sure it's going to give us a warning that the timing is not accurate. But let's try it. So I say time it. I define a function handle to this function. Okay. So this is a function handle symbol. It doesn't have any input arguments because I'm defining the function to be get fact of 100, right? So I'm already giving it a pre-specified input value, 100. Okay. So what am I doing? I'm using time it function that takes another function as input, a function handle. How do I define a function handle? If you remember, I use @ and then parenthesis. Inside the parenthesis goes any input argument to the function, to this function, get fact. But I am already giving it the input number, so there's no need to define the input argument here. So I'm saying use 100 as input integer to get fact in order to time it. Okay. So now using this, I can say time this for me. And it says it takes 5.4 times 10 to the -6 seconds. So basically 5 microseconds. 5.5 microseconds. Okay? So if I say 150, do you think what do you think the number should be? Bigger, smaller, the same? It should be bigger, right? It's actually less. So the reason is that That's actually a very good point. You know, why does this happen? So I calculated the time of get factorial 100, and it was bigger than get factorial 150. Why is it so?
Well, since it's inaccurate.
Yes, it says it's inaccurate. The reason is that the CPU, so when you're performing tasks, CPU has also a lot of other things that's doing right now with your operating system, a lot of other things. And those things can affect the timing of the function that you're testing, right? And there is another thing. You should always keep in mind that MATLAB has a first-time cost function. I'm sorry, the first-time function called cost, meaning that if you're calling your function for the first time you have open MATLAB, then it's going to take longer than usual to finish the task that the function is doing. So if you time your function for the first time, it's going to show it bigger than when you time it more than one time. So like the second time or the third time. So if I try this again, so if I say 100, you see this time it's now 1 times 10 to the negative 7 for factorial of 100. If I try it again, it's negative 8. You see, it fluctuates. It's because the CPU on this time scale is quite random. It's doing a lot of different things, and sometimes it's idle, so it can do what you want immediately. Some other times it has to wait for another task that it's doing with operating system, and then get to this function. All right. So now, what we are going to do in the next 5 minutes, we're going to solve this problem with, the get fib. So the question is, download this function get fib. We cannot see it here. So you open this function, and then the goal is to add the time it function to this fib function, so that in addition to the Fibonacci sequence, it also outputs the time it takes to run the function, to finish the task, to get the Fibonacci sequence. How would you do this? Exactly. So what you would do is that we want to, the part that is doing the core of the calculation is done in get fib, right? So we have to time get fib. We don't need to time fib, because fib contains a lot of redundant stuff that is just for robust coding. So what we need to time is get fib, right? So how would you time get fib then? Where do we output the results for our for this function? Where does the output happen? Where does the function end here? It ends here, right? So I say Fibonacci of this input number is the output, right? And then I say return. So wherever return appears, that should be the end, right? So now I want, in addition to calling this giving the user the Fibonacci sequence, I want to also give it the time it takes for the function. So I say time of get fib of this number equals what? Now instead of giving the number sequence, I want to give it the time. So I would say time it at get fib. What is the input value here? N, exactly. So N. So now this should work. Let's call this function now. Let's copy it and put it in a function here. Save this as fib on desktop. Now if I call fib, unbalanced brackets. So you see MATLAB gives us the line that there is a problem. So I think there is, okay, now it's correct. So what I'm doing is that in addition to getFib call, the original getFib call, I'm also timing the getFib function using the same input argument as user requested, right? So I'm creating a function handle to getFib without any input arguments, but I give it the input argument explicitly using the value n that I have defined, right? So now I say fib, it says enter a number, let's enter 10. It says fib of 10, the Fibonacci sequence for 10 is 55, and the time it takes for get fib of 10 is 1 to the negative 10, 1 to the times 10 to the negative 5. Now if I say not 100 is too big. Let's try 20. It says it takes 1/1000th of a second. Let's try 30. Takes really long time. 13 point to the, so it's 1/10th of a second. So if I try 40, it's going to take a while. So we can leave and come back later on Friday. On Monday, actually. So.
I was going to ask a question regarding yesterday's functions with the largest prime. Yes. I tried to make it clear and manual built-in.
Okay. Can you show up my office hours? Okay, awesome. That'd be great.
Yeah, at 3. The office hours 3 to 4 today. Yes. So it takes a long time, so I'm going to stop it anyway.